Ladies and gentlemen, welcome. We are going to look at some basic questions. So, these molecules act as molecular chaperones to assist the folding of proteins. A, vitamins, B, carbohydrate, C, amides, D, lipids. So generally, most of the proteins that we synthesize in our body, they are in their linear form. And if they're in a linear form, it means that they're unfolded form and they cannot actually carry out their activity. And the proteins are usually folded using some of the biomolecules like molecular chaperones. So molecular chaperones are very important molecules that assists in folding proteins into its dimensional structure for it to have its activity. So of course, a lipid is one of the molecular chaperones, or is one of the molecules that have or that act as a molecular chaperones in folding protein into its 3D shape for it to carry out its activity. So the answer to these questions is lipid. So lipid can act as a molecular chaperones that help in folding and twisting proteins. So any unfolded proteins, in many cases, they doesn't carry out any activity. So another question, which is question 2, which of these is not a lipids? Fats, B, oils, C, proteins, D, waxes. So of course, ladies and gentlemen, fats, oils, and waxes are lipids. So proteins is not a lipid, it is also a class of macromolecules on its own. The abundantly distributed enzymes in germinating seeds and adipocytes is lipase, proteases, cellulase, nuclease. So generally, ladies and gentlemen, germinating seeds and adipocytes are the major sites where lipids are stored. So that is why lipase enzymes are highly rich in germinating seed and adipocytes, which actually they assist these germinating seeds and the adipocytes in utilizing the lipids in energy generation and other physiological process. So that is why lipase should be highly distributed and it should be highly abundant in germinating seed and adipocyte because there are abundant lipids that are stored there. So for the lipid to be mobilized, it needs lipase enzymes to assist in metabolizing and utilizing the lipids. So lipids are a diverse group of organic compounds that are insoluble A, in water, B, alcohol, acetone, all of the above. So generally, actually, due to the heterogeneity nature of the lipid cannot be defined based on its structure or based on its chemical nature. Rather, lipids are defined based on its solubility. So generally, lipids are insoluble in water. So lipid is insoluble in water, but soluble in organic solvent like alcohol, ethanols, acetone, and others. So therefore, lipids are a diverse group of organic compounds that are insoluble in water. So the answer is D. So which of the following is a major functions of lipid in the body? Of course, lipid has so many functions. So number one, lipids serve as a storage or serve as energy storage. In fact, lipid is one of the class of biomolecules that stored the highest amount of energy. In fact, in 1 gram of lipid, you can have 1 calorie, or let me say that it's 4 kilojoules per mole of energy. So lipid is serve as a storage form of energy in the body. Although carbohydrates produce energy, proteins also produce energy, but because of the reduced nature of the lipids, so it stored more energy than the carbohydrates. Although the energy in the lipid are usually utilized when carbohydrate is exhausted in our body. Then B, the structural component of the cell membrane. Of course, lipid can serve as a structural component of our cell membrane. And yes, again, lipid is also very important in synthesizing hormones, especially steroid hormones, because remember, we have different types of hormones. We have steroid hormones, or we have protein hormones, we have steroid hormones, we have amino acid derivatives. So generally, the steroids is a lipid on its own. So that is why lipid can also be used in the synthesizing hormones. So the answer to this question is all of the above. So all of the option A, B, and C are correct. So the basic building blocks of lipids are A, amino acids, nucleotides, fatty acids, and then monosaccharide. The answer is fatty acids. So the basic building blocks of proteins, or the basic building blocks of lipids, is fatty acids. And then the basic building blocks of proteins is amino acid, and the basic building blocks of nucleic acid, which is DNA and RNA, are nucleotides, while monosaccharides serve as a basic building blocks of polysaccharide like sugar, glycogen, and the rest. So the answer to this is option C, which is fatty acid. So fatty acid is the major building blocks of lipids. So then the next one is saturated fatty acids. So saturated fatty acids have single bond between carbon atoms, double bond between carbon atom, both single and double bonds between carbon atoms, and D, no carbon atoms. So the answer is actually in saturated fatty acid, there are fatty acids that in their carbon chain, they all have single bonds. So they all have carbon to carbon single bond. So the answer to this question is option E. So between the carbon to carbon, they all have single bond. But of course, for the double bond, it's actually unsaturated fatty acids. So when you have fatty acids that have double bonds, or single and double bonds, so that fatty acid are classified as unsaturated fatty acids. So what are the unsaturated fatty acids? So unsaturated fatty acid A have single bonds between them. B, double bonds between carbon atoms. They have both single and double bonds between carbon atoms. So actually the answer is in unsaturated fatty acids, we have at least one or two double bonds in them, or triple bond. So it means that they have both double and single bonds in them. So the answer is C. So option C is the answer. Option C. So now let's move to another question. So which of the following is an example of a saturated fatty acid? So that is a fatty acid that have single bonds throughout. So linoleic acid is unsaturated, oleic acid is also unsaturated, palmitic acids is also unsaturated. So the answer is stearic acid. So stearic acid is an example of saturated fatty acids. So you can actually check and see that in the saturated fatty acid, there is no any single bond. So then the next one is, which of the following is an example of unsaturated fatty acids? Examples of unsaturated fatty acids. So linoleic acids is linoleic acids, oleic acids, stearic acids, and palmitic acid. So ladies and gentlemen, let me just give you this hint. Let me just give you this question to answer. So which of this is an example of unsaturated fatty acid? Please, if you know the answer, write the answer on the comment section. Yeah. So then now, which of the following lipids is commonly known as good cholesterol? So generally, cholesterol in our body, they have their normal range. And if the exceeds, or if they are above that normal range or below normal range, it means that it's a problem. is a problem. So therefore, the cholesterol should always be maintained within the normal range. So in most cases, most of these cholesterol are deposited in our artery, and it is very bad cholesterol to be in our artery because the plug or the foam, a flagule on the walls of our artery, which make the flow of blood to be very difficult. And as a result of that, it usually creates a high blood pressure, and the condition is described as atherosclerosis. So, but we have some lipoproteins that help when those cholesterol are deposited on the wall of our arteries, then they will now pack them from the artery and take them back to the liver where they are utilized and used for the synthesis of other important molecules. So those lipoproteins that actually transported those cholesterol from the from the artery to our liver, they are considered as a good cholesterol. While those that actually transported the cholesterol from any part of the body to the wall of the artery or from the liver to the wall of the artery, so those ones are considered as bad cholesterol. So which of the following is that good cholesterol? That is those that pack cholesterol from artery to the liver. So the answer is high density lipoproteins. So this is what is described as a high density lipoproteins is described as a good cholesterol. Then the next one is which of the following lipid is commonly known as bad cholesterol. So the bad cholesterol here is low density lipoproteins. So pack cholesterol from the liver and take them to the artery. So high level of low density lipoproteins can actually increase the chances of coming up with cardiovascular disease. So then another question is which of the following lipid is the most abundant type found in the body? So the most abundant types of lipid that are found in our body is triglycerides. So triglycerides is the lipid that is mostly found that have the highest percentage in our body. Then the next one is triglycerides. So triglycerides are the lipids that actually made up of fatty acid and glycerol. So it's actually made up of fatty acid and glycerol. So one glycerol is ester 5 with 3 fatty acids. So the answer is A. So that's right. Ethyl glycerol, it contains one glycerol and 3 fatty acids. That is why it is called triglycerides, because 3 fatty acids are attached and one glycerol. So the answer is E. So then next one is which of the following is the functions of triglycerides? The functions of triglycerides: E, long-term energy storage. Yeah, this one is correct. So the triacylglycerol is stored energy in our body for a long time. And then B, insulation and protection of organs. So generally, that is why you find it in most of the people, so in most of the fat people, they usually protected with their cold weather because their organs is highly protected and covered with this triacylglycerol. So that is why it serves as a thermal insulator to humans. So it can serve as insulator or insulating material, and also it protects our organs. Then number C, option C, it also helps in absorption and the transport of fat-soluble vitamins. So therefore now, the correct answer to this is all of the above. So all of the three options above are correct. All of the above options are correct. So then the next one is phospholipid has or have a hydrophilic heat and hydrophobic tail. So the hydrophilic heat is composed of, so generally most of the lipid are hydrophobic. That is, they doesn't interact with water. But in the case of phospholipid, they has both hydrophilic and hydrophobic tail. So the hydrophilic heat is what make the phospholipids to be water soluble. So what is actually the major component of that hydrophilic heat is phosphate group. So it's phosphate group that's actually found on the states of the lipid, and that is what makes it to be hydrophilic. Then, which of the following is a function of phospholipids? It helps in maintaining the cell membrane structure and integrity. It helps in cellular signaling, transport of lipids in the bloodstream, and then energy storage. So actually, the major functions of phospholipid in our body, it helps in maintaining the structure of the cell membrane and its integrity. So the answer to this question is option E. So option A is the correct answer. So then the next one is, which of the following lipid is involved in hormone synthesis? A, glycerides, triglycerides, B, cholesterol, C, phospholipid, D, steroids. So remember, ladies and gentlemen, I made mention that we have different types of lipid proteins, hormones, steroid hormones, and amino acid derivatives. So it means that the steroids is one of the lipids that actually help or that assist in hormone synthesis. And examples of the steroid hormones, we have testosterone, estrogen, are the examples of the steroid hormones. So they are synthesized from steroids. So ladies and gentlemen, thank you very much. If this is the first time you came to my YouTube channel, please subscribe and join the YouTube community as we are going to upload more videos. Thank you and bye-bye.